Hi, my name is Katelyn Bier, and this is my molecular portfolio on the drug Cefzil. Its brand name is Cefzil, and its generic name is Cefprozil. The chemical name is rather long, so I am not going to try and pronounce it, but I have inserted it to take a look at. But now we're going to move on to some facts about Cefzil. It is used to treat bacterial infections such as bronchitis, or infections in the skin, ears, sinuses, throat, tonsils, etc. The medication works in a way to stop and prevent bacterial growth and regrowth, and you should not use it if allergic to penicillin or the antibiotic that I have listed, and it may cause false positives on diabetic urine tests and blood glucose tests, and it does not work for colds and flus since it is used to treat bacterial infections. Moving on, we are going to draw the line bond structure of Cefzil. And okay, so we are going to start with some carbon. Oops. And we are going to make, and then branching off, we're going to have two oxygens, one with a double bond, and we're going to make sure to fill our octet rule, and then we are going to have some double bonds right here. And this is a sulfur, and this is a nitrogen. Next, we're going to have a double bond oxygen here, octet rule, and we have a hydrogen there, and then this is a nitrogen, fill our octet. We have a hydrogen, and we have another hydrogen, don't want to forget that one, and then we have that, then another double bond oxygen, that one's a little wonky, and we have another nitrogen bond here with two H's this time. Then we're going to fill our octet. And this one has double bonds throughout it. Then we have a branch of a oxygen and a hydrogen with a fill our octet rule. So this is what Cefzil looks like in a line bond structure. And moving on, we are going to look at the expanded structure of Cefzil. So here we can see all the carbon and hydrogen and oxygens, nitrogens, all laid out. So with the expanded formula, we can move on to the molecular geometry of Cefzil. And Cefzil has 4 different types of geometry in it. It has trigonal planar of 120, trigonal pyramidal of 109.5, bent 109, and tetrahedral at 109.5. We're going to start with trigonal planar with 120, and we're going to be doing that one in red. So we have this one, this carbon. We can tell it is trigonal planar because it has it has 3 bonds coming out of it. Okay, next we're going to move on to trigonal pyramidal, which is we are going to do in blue. And it's going to be this one, this nitrogen. So just all the nitrogens. And then we're going to move on to bent, which is in green, which is going to be this sulfur, this one, and this one. Next, we're going to move into tetrahedral, which is going to be in orange. And it's going to be this carbon, this carbon, this one, this one, this one, and that is all of the bonds. So that is the molecular geometry of Cefzil. And so now we can move on to look at the molecular formula of Cefzil and find the molar mass. We have the formula, which is C18, H19, N3, O5, and S. And so when we find the molar mass of any molecule, we break down all of the elements and how many, and then we find the atomic mass, multiply it how many we have to get the result of how many moles of each element we have. And when we find the moles of each element, we are able to add them all up to find the molar mass of this molecule. When we add all the moles up, we get a total of 389.396 moles of Cefzil. So with that, we have found the molar mass, and we can move on. So when we look at hydrogen bonding with water, we are going to look at an example first. So this was an example we were given, and we can find the H bond acceptors and donors. So when we're looking at it, we find that H can be an acceptor and attached to a oxygen with two H's, and then off of N, O, and F's, we can attach it to an H, which is then attached to an oxygen and another hydrogen. And all the N, O's, and F's are going to be hydrogen bond donors, and hydrogens are going to be hydrogen H bond acceptors. So after looking at an example problem, we can go into what hydrogen bonding with water in the drug Cefzil looks like. So we are able to look at all the O's and the H's and the nitrogens in this drug, and so we are able to determine the H bond donors and acceptors throughout the entire drug, which I have done for and inserted a picture of. Moving on, we can find the polarity and solubility of Cefzil. The polarity of Cefzil is the bonds between the O's and the N's and the H's. And so the nitrogens and the oxygens have a higher polarity than the hydrogens. So we are able to put the S negatives on the oxygens and the nitrogens. And so then we can find the solubility. And the solubility of Cefzil, I would say, is soluble in water. I would think that it is somewhat soluble because of the polar and nonpolar bonds, and according to Cefzil, it is somewhat soluble in water, not fully, at 0.55 mg/ml. Moving on from polarity and solubility, we are able to answer problems based off of our drug. So we have this question that I have inserted a picture of, and we want to prepare 50.0 milliliters of 2.30 times 10 to the negative 2 mole solution of our drug, which is Cefzil. So we are and then the next question, calculate how many milligrams of the drug are contained in 2.0 ml of 3% solution of your drug. So when we have these two questions, we are going to focus on the first one first. So up in the corner, I have all the numbers that we were given, and we find the formula that works best for the problem, which is M equals mole over liters. And we were able to rearrange the formula to then get M times L equals moles, since we are solving for moles. So we can plug in the two numbers that we were given and solve for this question. So when we were given 2.30 times 10 to the negative 2 moles times 0.0500 L. So then when we solve that, we are given this answer, 1.15 times 10 to the third mole of Cefzil. So with that is our first answer that we will plug into our next equation, which you can see that it is plugged in right here. So after we plug it in, we are taking the molar mass of the drug that we solved in the previous slide and plugging it in over 1 mole, so we are able to cancel out the 2 moles to then multiply these two numbers to then get our answer of 5.84 times 10 to the negative 1 grams of Cefzil. Moving on to the second part of the question, we are given two completely different numbers, which we are right here, And this is the formula we will be using. So we are able to rearrange the formula into this, which is solving for the part of the equation that we want to find. So we can plug in the 3.0 here, and then we have the 2.0 there, over 100. So when we solve, we get 0.060 grams, but grams are not what we want milligrams. So this right here is the conversion factor for milligrams to grams. So we are able to plug that into the equation to get 60 milligrams as our answer. When we move on, that is the end of my molecular portfolio. Thank you.